we can good audio quality. Okay, so good evening, everyone. Thank you for joining the Area 52 January STEM Forum. So we are going to be recording today's session. So again, if everyone in the audience can mute themselves. So before we get into today's topic, I'm just going to give a quick introduction of our team. So my name is Isaac. I'm a member of First Tech Challenge Team 18227, Area 52. We are a community-based robotics team out of Plano, Texas, and this is our fifth season competing. Our last year, our team advanced to the World Championship for the first time, and we finished as semifinalists in robot performance, and we also received the second place Think Award. And besides building robots, our team is also very active in spreading robotics and STEM in the community, from teaching kids about robotics, mentoring robotics teams, doing robot demos at local events, and hosting webinars like this. So we started the STEM Forum 2 years ago, inviting industry professionals to share their experiences and insights on trending STEM topics. So today's webinar is the fourth one of this season, and you can view the recordings of past STEM forums by searching Area 52 FTC on YouTube. So next, I'm going to introduce our speaker for today's session, Mr. Joshua LittleSun. Mr. LittleSun serves as the Chief Technology Officer of Synapse ITS, a comprehensive transportation technology platform focused on increasing roadway safety, accessibility, and efficiency through innovative infrastructure. Mr. LittleSun is a tolling industry expert with over 20 years of experience in designing and delivering large-scale infrastructure projects. So if you've driven on a toll road or crossed a street, you probably used a system designed and implemented by Mr. LittleSun and his team. So these projects combine a wide breadth of STEM degrees, including civil, mechanical, electrical, software, and AI or machine learning engineering. So for today's session, Mr. LittleSun will share with us his insight on the business side of STEM and tips on how STEM students can stand out in the workplace. So just some quick logistics before we start. If during the presentation you have any questions, just put them in the chat and we're going to collect the questions and then we will answer them during the Q&A period at the end of each section. So without further ado, please join me in welcoming Josh LittleSun and his presentation, The Business Side of STEM.
Wow, thank you. I'm so happy to be here. Thanks, guys, for inviting me. So yeah, as Isaac said, we're going to kind of walk through today a little presentation on what is the business side of STEM. So again, my name is Josh LittleSun. I have about 20 years in this little industry called Intelligent Traffic Systems, ITS. You probably have never thought about what I do, and that's good. You should not think about what I do. But ITS comprises a lot of different things. Pretty much if it's on the road and it is intelligent, like it has brains, it works. I have probably had my hands in it, specifically tolling, weigh in motion sensors. You know, you guys go down the roads, you see those places that asks for the trucks to pull over, and crosswalks. So I've worked on all of those different systems, and that what we're going to talk about today is how do those systems actually get into production? Like what is those things and how do STEM majors make that happen? I'm oftentimes asked, while ITS seems boring. I'll be honest with you. You're probably not going to go to school wanting to be part of ITS. But I want you to take a look at this picture and I want you to think about, take the cars out of the picture and just think of how many different STEM degrees does it take for this road to be built? Just think about it for a minute. And while you do that, I want to say this. I am an engineer, but I love learning new things. That's part of what makes us as STEM majors or as STEM people. It makes us what we are. It's at our core, our thirst for knowledge, our love for new things. And working on large projects like this allows me to have interactions with all sorts of different people, not just other electrical engineers. I'd probably lose my mind if I had to just interact with other double E's. So just on this project, which is a project I was an engineer for, this is all the different types of other engineers I interacted with and I got to learn something from. So everything from hydrologists, mathematicians, traffic engineers, biologists. You don't think when you look at this that a biologist is going to be involved, but you do get to interact with them. So all these different types of degrees are necessary in order to make this road active, make it a thing. And the world does not run without these type of roads. But there's more to what we do than just the STEM degrees, right? There's a lot of other degrees that go into this. So for every degree that is a STEM, there's all these other people that are interacting with us to support the STEM to support the scientific, the engineering, and to make this a reality. So these are all the other different types of people I get to interact with doing what I do. And I'll be honest with you, I've learned something from everyone on this list. Everything from urban planners, where the road should be, how much should we charge for the road, how to actually like safely get out into the road to do this, the equipment. All these different types of people are necessary in order to make these projects like come to fruition, to be real. And that's what I love about what I do is I get to interact with, I'm not pigeonholed into just talking to other engineers or computer science people. I get to do all sorts of different things. So why should you care? Well, when you go off to school, you're going to learn some sort of technical capability. More than likely, if you're in this call, you're going to become a STEM major. And college is going to teach you that technical capability. And that technical capability makes you useful for a business. No, but if you can learn the business side of whatever you get involved in, you'll be very valuable to your business. Okay. And that business knowledge generally only comes from experience. And when I say business knowledge, I'm not talking about like learning business as a degree. I'm talking about how does what is the problem you're solving? How much can you charge for it? Who is making the decision for the business? How do they make that decision? And how do you get paid? That stuff only comes through experience and getting that interaction. But there's a third option here. If you can learn both the technical and the business, you will be invaluable. And being invaluable to a business is very important. Invaluable employees can make demands. You can ask for that pay raise. You can ask to work where you want to work. You can ask to work on the projects you want to work on. So I'm hoping that this presentation is your first interaction to how do you turn yourself, not just from a good technical person, not just a good STEM, whatever you want to be, but how do you take that step and what do you need to do to start learning the business? So I'm going to give you a business 101. How do things actually get, like large projects actually get done from a business perspective? So if you go off and you ask any business major, hey, how do projects happen? They're probably going to give you something like this. It's going to be 5 phase. It's got a bunch of words, sounds very formal. Don't worry about the formalness. Today, we're going to make this very simple. In order to make business happen, 5 things need to happen. The first thing is you got to know about the work. You got to know it's upcoming. You got to know who has the problem and what problem do they have. Then you got to go convince them that you're the person to solve that problem. Then you actually got to go make the thing that you promised. Then you got to prove to the person that you're buying, that you're selling it to, that it does indeed work. And then you got to maintain it. Those 5 things are fundamental to any business problem. And every business does them slightly different. Every business has slightly different timelines for them, but that is business fundamentally. So we're going to go through what does this mean in the big ITS space. How do I know about my work? How do I win my work? How do I execute my work? How do I test it? And how do I maintain it? So consider this a crash course in business. So knowing about the work, it, obviously it's the pipeline of the work. You've got to know that someone has a problem and that you are the person to solve that problem. And while you're doing it, you hopefully want, while you're out there finding out about the work, you want to make the customer think that you're the person to solve their problem. So who does this? Most businesses, this is done with a department called sales and business development. What do they do and where do they do it? Well, these are the guys that go to conferences. These are the guys that go to events. These are the guys that wine and dine customers and do road shows. They're always on the road. They're always traveling. These are guys that if you want to get into the American Airlines lounge, They're the guys that have access because they travel all the time. So in my business, this phase can take up to 2 years. So that means from the time we make contact to a customer, an agency, someone who wants to build a toll road or put in an intersection, from the time we make contact to them to the time that we actually are selling them a product is potentially 2 years. We have to contact them constantly for that 2 years. Okay. That's a lot of time. So, what are we doing during that 2 years and what makes these guys valuable? Almost every STEM major I have ever talked to, when they first get out into the business world, they think that the business development guys are useless. They don't like them. They just think they talk and don't deliver anything. Let me break that mold for you right now. A good business development guy is invaluable to you, and you being friends with them is super important for your career. It is a skill. They have to be out there in front of a customer. They have to be able to talk to that customer, understand that customer's problem, and get that customer to trust both them and the organization they represent. That means listening and translating concerns. That could take a long time. That means guiding the clients into understanding your product and understanding that you can solve their problems with your product. It's a lot of back and forth. It's very frustrating sometimes. Influencing that customer and providing feedback to you as a person who's the technical people, it takes a lot of patience. And they have to do all of this without annoying the customer or annoying you. Otherwise, they can't do their job. This is a very hard skill set. When they do it right, it's invaluable. And part of doing it right is getting input from the technical folks. So once you become that technical expert, once you get that degree, you get out there, these business development guys are going to be looking for you to give them information. Because if they don't do their job right, it causes chaos. What kind of chaos can it cause? Well, they could sell things that don't exist. They could overpromise the product in the timelines. Or they could just sell products that break the laws of physics. So bad business development guys, 2 out of 3 chance they end up in jail, apparently, according to this little survey here. But it is definitely not something that it is something that takes skill and is something that takes time. Okay, so now we're going to do a little fun game here. I told you it takes 2 years. So if I'm running a business, 2 years is a long time. What you're looking at here is what's called a burn down chart. It's by year, by quarter, how many people do I need in this phase of the project? And how much money am I going to spend every quarter, and then a running total. And I also have put down here the number of technical people. After each phase that I've talked about, those 5 phases, we're going to check in here on how much money have I spent as a business to do this phase. So for this particular phase, if I just dedicate 3 people to doing business development, and I say it takes 2 years from the time I make contact to the time I actually have something to go commit to, I have potentially spent almost $1 million. So this business development phase is very pricey for every company. You spend a lot of money here because this is your pipeline. This is the thing you need to spend money on in order to know about the work. So these type of numbers usually blow people's mind on how much money it takes to do this work, but that's how much it takes, guys. So, okay. So we've gone out, we've talked to clients, we know that there's work. Now we got to go win the work. So how do we do that? So we've talked to the client, we've hopefully kind of convinced them that we're at least potentially capable, and now we got to go actually formally win it. So how do we do that in the ITS space? This is done through something called an RFP, a request for proposal. What is an RFP? An RFP is during those 2 years, that client has written down all of their requirements, everything that you have told them, others have told them, everything that they have internally created. They will put that into a document that will outline the work they want to happen. So in my world, an RFP could be 300 pages, it could be 1,000 pages. It is a very lengthy document. Okay. So these RFPs go out to everybody and or everyone in the industry that the customer thinks can do the work, and we have to respond to these RFPs. So who does it? It's the whole organization. Everyone's involved. But it is generally led by the business development and sales team. So it's still in the sales cycle, but you as a technical person will probably have to begin getting involved in RFPs sooner than you would get involved in the first part of this. So that is what an RFP is. But what is an RFP? Like, what is it? Like I said, it is a summary of the work. It's generally has a high level, here's the project. Then it has technical requirements. Most cases, it's going to have personnel requirements. Like they're going to describe, I want someone with this amount of experience. I want someone that has done this before, blah, blah, blah. Then it's going to have testing requirements. This is the way I want you to test the thing you're delivering to me in order to get paid. And then it's going to have a bunch of other documentation. If they want you interacting with third-party systems, they're going to give you API docs, programming interface docs. They're going to give you diagrams, drawings, all sorts of stuff. And you are going to have to respond to every bit of this RFP. So if it's a 1,000-page RFP, you may have to write 2,000 pages to respond to it. And then you're going to get scored. Something I want you to notice here. Despite the fact that us STEM majors like to think we make the world go round, on these RFPs, the technical score is usually only about 30%. So you can have the best technology in the world, you're only get 30% for it. A lot of business is not completely constrained by the technology that you're delivering. It's constrained by a lot of other factors as well. Your personnel, your approach to the project, and then finally your price. This is real scoring criteria that I face pretty constantly in my world. Um, and yeah, that's the way it works. So you got the RFP and you got your scoring criteria. And then you have a deadline. So how long does it take to do an RFP? This is from a real RFP. You're going to see all the steps it takes to get from the original RFP draft to the time they actually are going to give you the contract. And I want you to notice it's almost a year. You're going to be in an RFP phase, or responding to an RFP for a year. This includes a lot of different things. Some of them are going and talking to the customer, having written questions. They're going to then do mandatory site visits where they're going to like come out and see your stuff in operation at other clients. They're going to do one-on-one sessions. There's all sorts of back and forth during these phases for these big projects. This is not a let me throw you a document and throw you a price and you select somebody. This is a long dating process where you're going to get to know each other very well before they select somebody. But what are you going to be required? What are you going to be responding to? Well, these RFPs, generally the bulk of that is going to be requirements. And these requirements are not necessarily simple requirements. If you read this requirement right here, all connections to the system, just assume this as the system, and the cloud console and user interface shall be secured using a zero trust architecture approach with compliant NIST SP 800-207. What do I do here? How do you tell the client that you're going to be doing this? How do you respond to the client? How do you give a price for this? How do you estimate the time it's going to take? How do you estimate your testing? How do you estimate anything, right? This is where the real skill of the technical and the business come together, of being able to understand the requirements that you're going to get during this phase and breaking it down and understanding. Generally, this is done with your architect team. I joke because I think there's actually a couple architects that used to work for me on this call that are probably laughing right now that know that this is very difficult. This is where the real money comes into play. So you have to spend a lot of time really understanding these requirements and understanding how those requirements impact the system that you're delivering. Because if you do it wrong, it's money. If you overestimate, you're not going to get the job because you're going to overestimate it and they're not going to go with you. If you underestimate it, if you do get the job, then you're going to lose money in doing the requirement. So there's a lot of work involved there to try to get this balance correctly. And there is no class you're going to take in college that's going to teach you how to do this. This is a pure experience thing. Okay, so checking back in. Oh, wait, before I do that, I want you all to think, how much money do you think I spend on this RFP? How much money? We were at 1 million. What do you think we're at now? Okay, well, the way I see it, in order to do an RFP on one of these big projects, you're probably going to have about 10 people working on that RFP, off and on, but about 10 people for the year working on it. 3 of them are going to be technical, if you're lucky, and the rest of them are going to be non-technical personnel. But total, you're going to spend about 1.5 million on an RFP. And you add that to that million we had before we have earned a single penny into our business, we have spent $2.5 million going and knowing about the clients and then going and actually responding to RFPs. So if that surprises you, please ask me a question. But I don't see any questions in the chat, so I think we're good, Isaac, to keep going. Yeah,
Yeah.
cool. All right. So we have gone and we have talked to the clients. We have gone and we have put an RFP out. Now we have been successful. We have sold the client our product. Now we have to go execute. How do we do that? Well, how do you execute the work? Well, generally, this is going to be done with 3 different major teams. The first is going to be the project management team. Project management teams, most technical people hate the PMs. Don't know why, but they do. But the project management teams are responsible for delivery of a project. They are the ones that are the forward-facing leaders of the project. They control your finances, your schedule, your scope. Then you have your technical teams. So civil engineers, mechanical engineers, developers, whatever. And then you have what I call support teams. These are the teams that help you do things that are outside of the core technical competency, documentation, um, uh, business systems analysts, all those type of things that are not specifically technical. And how do you do all of this? Well, obviously, if you're delivering a large project, you're going to need a schedule and a project plan. And more than likely in the modern world, you're going to need some sort of agile team working on agile teams working on different parts of the project. How long does it take? Generally, to get through this phase, about 12 months for the projects I work on. Again, these are large projects. Not everyone takes 12 months. So there is something that you're going to get involved in if you're not familiar with this. There's 2 major schools of thought of how to approach big projects. The first one is called the waterfall. This is basically a little bit of an older school, but you can think of it like building a house, right? You lay the foundation, you put the framing up, then you move on, and each phase has to be finished before you move to the next phase. Then there's Agile. Agile is a little bit of a different approach. It is more of an iterative approach where you can kind of work on stuff, make mistakes, fix whatever you made a mistake on, and iterate from the ground up till you're complete. Okay. If you have to build software or even engineering, like I do with uh other with embedded systems, everyone's going to tell you Agile is the superior way, and they're not wrong. It is. It is the superior way if you get to do it without any constraints. But it is the worst way to build software and get paid for building the software. So while a lot of people want to use Agile, honestly, you're only going to get paid using waterfall at the end of the day. And why is that? Going back to that requirement, If you're a customer and I have told you I want you to deliver this requirement, and you have told me delivering this requirement is going to be $500,000, say, it's like, okay, it's going to cost me $500,000 to get this thing done. I am not going to pay you a single penny until it is completed. So if you're using an agile approach where you're just iterating and continuously to improve, continuously trying to get to where you want to get and continuously making improvements, the client is never going to accept it because they're constantly going to be saying, well, this cycle you did this, but I think it'd be really cool if you could do this the next sprint or the next epic. And you're just going to constantly spin on this. This is why Agile, while everyone loves it, it is a very bad way to get paid. No one pays using Agile, unfortunately. This is an actual diagram that a client has given us on the way we get paid in my world. And yeah, every, I'm not going to explain this, just be aware. Clients can come up with some crazy ways for you to deliver projects, like very unique and clever ways in order for you to have to deliver a project and you get paid. This is chaos. And this is what it takes sometimes on these bigger projects to execute the work. All right. So kind of going back to the team, all right? So what does a team look like that delivers this? Everyone you see in blue is a skill set that is required on a project of this size. And you'll notice very few of them are, well, what, one, two, three, four, five, six. Six of these boxes are STEM majors and the rest are non-STEM majors. So you got the program managers, account executives, you got the contracts team. Anytime you're working on projects like this, you need contracts team, you need PMO, project management, and then all the other team members. BSA stands for Business Systems Analyst, and TW stands for Tech Writers, by the way. I should mention this little presentation right here. If you came to work for me straight out of college, you'd be getting a much more in-depth presentation here, so you would understand the business. So some of this uses terms that are a little esoteric. Sorry. So that is the team that it takes to do a project. You'll notice there's a lot of people here, a lot of different developers and engineers. Oh, hopefully you didn't see that. So now the next slide is going to be the price. So again, what is the profit margin in ITS? Oh, Sarah, that's a proprietary. I don't think I can tell you that. So how much money do you think we spent? $8.5 million is where we spent so far. Oops. It's a good question though, Sarah. So that's it just from the point to this point, and potentially I haven't gotten paid that. I definitely have not gotten paid that much at this point to do the project. So that's how much you're spending. All right. And you'll notice again, this is the phase, the execute the work phase, where most of the like actual STEM, this is where we spend most of our time executing work. All right. Now we got to test our work. We got to prove to the client that we have done what they told us to do and that they are going to accept our work. How do we do that? That is generally done by a team called the quality assurance team. They get support from anyone. They get support from development, infrastructure, engineering, and all the other teams. We do this with multi-stage testing, automation, and in-person with the client, right? This generally takes 6 to 12 months, depending on what exactly the client wants to do. What you're going to see over here on the right-hand side is the classic V, right? So, and I'm going to answer your question right here, Sarah. So every time you see me go from a box to a box, from box A to like requirements to system to architecture to module to coding, this is assuming you're doing coding, you can put whatever you want here, whatever it is that you're doing. Every time I go from a box, there's what's called a payment milestone. I have to validate with the client that I have completed this phase and I get a payment milestone. And then when I come out of the V, I am testing my requirements against my acceptance test, my system design against my systems test, architecture design against the integration test, module design against unit test. So you go down and up. That is a very classic V design for testing. And like I said, every time you go box to box, you're getting some sort of payment. I will let you know, Sarah, most companies on the way down, you're cash flow negative, meaning you're not making money. You're just barely breaking even if you're lucky. Coming out is where you start making you money. However, you got to be very careful here. Going back to that requirement that I had, that was a big system level requirement. It is very easy when you're doing this breakdown of requirements to overlook something because this is a very broad requirement, right? And as you start breaking that requirement down into its components, sometimes things are missed. And then you'll find whatever you missed when you start coming out of the testing phases. So the further you get away from this yellow and you find a problem, the more it costs your company to fix it, right? So if I'm up here in systems test and all of a sudden I realize I missed something, I have to reset all the way back here to make the change I want to make, and it could cost a lot. So now you got to do this with between 4,000 and 5,000 requirements. So every time you break that requirement down into subsequent parts, you're doing it with 4,000 to 5,000 requirements, and then you're testing on the way back out. And like I said, the further away you get from that core technical capability that you're doing, the more it costs you to fix it if you have to. It is this right here is very tedious. All right. So now where are we? Well, at this point, we have tested our work and our customer has accepted it. So hopefully we're cash flow positive at this point, but we've spent $11 million to get to this point. So we have we've gone and we've talked to the client, we've won their work, we've executed and we've tested, but we've spent $11 million. Hopefully we've made more than $11 million at this point, but that's where we are. So, and we are 5 years into a relationship with a client. So this is not quick in my world. All right. Now we get to do what I actually kind of like, which is maintain the systems. So now we've gone and we've built these systems out, tolling or traffic signals, whatever it is. Now we have to maintain them. What do we do during the maintenance phase? Well, this is done by maintenance teams. These are usually a lot of like boots on the ground guys, like people who are there to maintain the system, but you also have a lot of support from if you're using cloud, you'll have cloud engineers, systems engineers, all sorts of other people involved. But on the maintenance side, what are they doing? They're doing something called maintaining SLAs and measuring KPIs. And we're going to get to what those mean in a second. And how do they do it? They use monitoring software, ticketing software, ITSM, if you know what that is. Don't worry if you don't. And how long do they do it? In my world, most contracts are base 5 years and an adoptional 5. So for up to 10 years from the time you install that system, you have to keep it operational. Sometimes it's up to 20 years. So you can imagine, I have been doing this for 20 years. Some of the systems I installed when I first was an intern are only now coming up for another competitor to bid. So that's how long the systems I build stay in operations. So I mentioned two terms there, SLAs and KPIs. SLAs are service level agreements, going all the way back to when I told you the business development guys are talking to the clients and they're taking the client's needs into consideration and saying, hey, what do you need? What are your problems? Those are codified in what's called an SLA, a service level agreement. You need the system to respond in 5 seconds. You need the system to send an event in 30 seconds to this other system. Those are SLAs. And those are defined all the way back at the very beginning. So by the time you get to maintenance phase, you're having conversations that started 5 years ago, which means there's a lot of history between the time that conversation first occurred and that time you're having the conversation at this point. And then a KPI is a key performance indicator. So I have an SLA, I have an indicator that tells me if I'm meeting that SLA, fundamentally is what you're doing, right? In my world, if you don't meet your KPIs, your key performance indicators, you have to pay the client. So I have to pay them something called a liquidated damage. So going to the tooling world as an example, you may have an SLA and a KPI that states that you will capture every car that goes underneath the toll zone with 99.95% accuracy, right? So every month you're measuring that accuracy. And then every month, if you're below that accuracy, the client may tell you, you owe me $5 per car that was underneath that 99.5. So sometimes SLAs are very pricey and can get out of hand very quickly. So this whole maintenance phase, people like to just kind of blow it off as like, oh, you're in maintenance, whatever. It's no big deal. But if you don't maintain the system appropriately, you could end up paying the customer thousands and hundreds of thousands of dollars based on these SLAs and KPIs. All right. So how hard could it possibly be to maintain these systems? All right, going back to this picture here. This is an actual picture of a roadway that I did. I want you to, I'll give you about 30 seconds to count how many pieces of hardware and do you think are in this picture that have network connectivity and software running on them? Because every time you see one of those, it means I need to be able to deploy somebody at a moment's notice to go fix that thing if it fails because I have an SLA and a KPI associated with it. All right, let's see how many there were. There were 18 devices that we are responsible for maintaining on that road. So just in that one picture, just this one little block, there are 18 devices. That's a lot of devices when you're thinking of maintaining 100 miles worth of road. That's how much devices go into these maintenance contracts. Lots of work. All right. So going back, what does the team look like? Here's the team. Kind of again, a lot of on-site people doing work. And now the next phase is going to be how much money do you think we've spent for the entire project from the time we started to the time we are here at the maintenance phase? All right, let's see if you're right. We are, oops, sorry. For 10 years of maintenance, I kind of combined everything. We will have spent about 20.5 million. So that's how much money it takes over the course of that 10 years to know the customer, win the work, execute the work, test it, and then maintain it for that time period that we're caring about. So that's the size of the projects you're working on here. All right. So what are the takeaways I hope you learned today? A couple things. First off, I hope you learned about how these large-scale system deliveries operate, how these big things get done. I also hope you understand what all the technical people do on these deliveries. Because if you ever come to work on these kind of projects, you may be an engineer, you may be a software developer, you may be something else, but you're interacting with a very large team. It's not just your skill set or your perspective that goes into these projects. I also hope that you've learned what will make you more valuable to your organization. I have a couple of takeaways for this. Number one, when you go and get your job, Make friends outside of your technical capability, outside of your team. It's going to be very easy. Like when I first got out of school as a double E, the only people I hung around with were other double E's, electrical engineers. Only when I started working with the business development team, the PM team, the QA team, did I start really making my understanding the business and making myself valuable. I hope that when you get out in the business, you learn why and how your company wins business. Understanding why do customers buy your stuff? Why do customers think what you do is worthy of their money? That's important for any technical person to understand because we can influence that a lot more than we really give ourselves credit for. And I want you to learn when you get out there, how does work come into your organization? I described one phase here. I described RFPs and the formal process I have to go through because I work with government contracts. But not everyone's the same. If you go out in the world and you start working as a chemical engineer, I very much doubt you're going to have the same work product on how work comes into your organization. Like, who has touched this project before it gets to you? Is it BD and sales? Is it a PM organization? How does work come into you? And then learn about how your company gets paid. What is important to your company? Is it units? Is it widgets? Is it software? What is it and how do you get paid for it? You need to learn that as a STEM major. And yeah, I think I wrapped this up pretty quick. That is what I hope you guys take away from this.